Hi, I'm Steve Gibbs. I teach electrical engineering here at the College of Engineering, University of Texas at Arlington, and today it'll be my privilege to begin to introduce systems of linear equations. This is a topic used extensively within electrical engineering. It's also used within the other engineering disciplines. Okay, our first question. What is a system of linear equations? Rather than immediately jump in and start talking in engineering terms like amps or ohms or volts or stress or something like that, let's take it back to something that we're all more familiar with. Let's suppose that I'm buying some apples and some oranges and some pears at the market. I find out that if I purchase 3 apples, 5 oranges, and 2 pears, then the cost is $2.10, or in American money, $2.10. Similarly, if I bought 5 apples, 1 orange, and 4 pears, the total would be $1.80. If I wanted to do things in even numbers and went 4 apples, 4 oranges, and 4 pears, the total would come to $2.40. But the real question, how much does an apple cost? How much does an orange cost? How much does a pear cost? In order to solve our linear equations, I'm going to simplify it just a little bit for our examples. Let's go ahead back and let's find just the price of apples and oranges. If 3 apples and 5 oranges costs $1.70, and 5 apples plus 1 orange cost $1.00, how much does each apple cost? How much does each orange cost? Now you notice that I went from 3 unknowns in the first equation, or first page, and 3 equations, to here I'm dealing with 2 unknowns, apples and oranges, and I've got 2 equations. We have a rule when we deal with linear equations that says we need as many independent equations as we have unknowns. So 2 unknowns, apples and oranges, means I need 2 equations. I also use the word independent. An independent equation means that it can't be directly related to any other equation. If I had these 2 equations, 3 apples plus 5 oranges costs $1.70, and then I added as my second equation, 6 apples plus 10 oranges costs $3.40, I would not have 2 independent equations because the second equation is merely twice the value of the first. So that would not add anything new. So I have to have 2 equations that are not related to each other. In order to solve linear equations, there are a number of techniques that we can use. In this series of studies, we're going to look at 4 of them. The first one, very straightforward, is substitution, where we find out what the value of one of the items is, and from that start substituting back in and ultimately find the price of all of the articles. The second technique is a graphical technique, and in this we'll be putting the 2 equations together in a way that we can look at a graph and see where the lines intersect, and that'll give us the values we're looking for. The third technique requires matrix algebra. Matrix algebra will go into solving matrices, setting up matrices, analyzing other terms related to them. This will be a separate lecture. This is going to be the lecture after this first introduction to linear systems. And then finally, we'll look at Cramer's rule. Matrix algebra is pretty complex. Works fine if you're using Mathematica or if you're using MATLAB or one of the programming languages, but Cramer's rule gives us a way to use techniques from matrix algebra, but to solve our equations fairly straightforward. So let's go on to the first of the techniques. We're going to use substitution. Then after we solve substitution, we'll move on to the others. Okay, let's take what we've just determined, that b equals 1 minus 5a. We'll substitute that into the first equation, and now we're going to multiply that out so that we have 3a I'm going to go for the 5a term next. So I've got 5 times minus 5a to get minus 25a. And 5 times 1 is going to give me 5.00. And that all equals 1.70. Collecting terms, we have minus 22a equals minus 3.30. And now we're solving for a. With this, we'll divide both sides by minus 22, and we find out that a equals 0.15 or 15 cents. Now we're going to take the solution for a and substitute it back into our equation for b. So if I know that 5a, 5 times 0.15, plus 1b equals $1, 1.00, reorder that so that I have isolated b, and b equals 1.00 minus 5 times 0.015. That's 5 times 0.15. And now we've got b equals 1 minus 0.75, or b equals 0.25. Now we know that apples cost 0.15 or 15 units, and that oranges cost 0.25 each, or 25 cents. So that's the first technique. That's substitution. So now we've solved that dimension. Let's go on and look at a graphical technique. Then eventually we'll get to matrix algebra and then Cramer's rule. Okay, let's look at the approach to solving this graphing equation. We'll start with our initial conditions. 3a plus 5b equals 1.70. 5a plus 1b equals 1.00. We will solve for one variable in terms of the other. So let's set up the equations. The first one, b, from the first equation, equals 1.7 divided by 5 minus 3a divided by 5. Our second equation, we have b equals 1.00 minus 5a. And then we'll plot the graphs of each equation. So on our left margin, we've got b. On our horizontal axis, or x-axis, we have a, and we find the point where the graphs cross. The blue line shows us the first problem. b equals 1.70 divided by 5 minus 3a divided by 5. The red line shows us our second equation, b equals 1 minus 5a. So you can plot each of them, and we find the point of intersection. And at the point where they intersect, the first thing we see is that the price of apples is 0.15. And simultaneously, we find that the price of b, which is our oranges, happens to be 0.25. So if you create the graph, you have a pretty straightforward, pretty quick answer or approach to get to the answer. So those are the first of our techniques. We've looked at substitution. We've looked at the graphical solution. In the next lecture, we're going to look at matrix algebra. And finally, in the last of the 3 series here, we'll look at Cramer's rule. So thank you, and I'll look forward to talking with you in the next presentation.